Alright, today's lesson is lesson number 93. We're going to be talking about simplifying radicals. Radicals, remember, are just square roots. We've done this before a couple of times actually, but I just want to really make sure that we know how to do this so that we're ready to move on to geometry. So let's go ahead and get started. Here are the steps. Okay, the first thing you're going to do, obviously if what's inside the square root is already a perfect square, then you just take the square root. So if I have, for example, the square root of 16, I know that that's 4. Okay, so I just write my answer. Okay, where it gets a little more tricky is if we don't have a perfect square right away. You want to try to factor out the biggest perfect square that you can. So if I have, say, the square root of 32, I know that that's just equal to 16 times 2 under the square root. Okay, so I'm factoring this 16 because I know that that's a perfect square. So I factored that from 32, and then that comes out. If I'm moving on, looking at step number 3, it says to rewrite the expression with squared terms. So I write this as 4 squared times 2 under the radical. And then I can take the square root of the square terms, and the non-square terms are going to stay inside the square root. Okay, so 4 is a squared term, so that I take the square root, it comes out as a 4, and then the 2 stays in the square root. Okay, so let's look at a couple more examples of this. Number 1 is the square root of 36. We know that 36 is already a perfect square, so that's just equal to 6. Square root of 12, well, that's not a perfect square, but I can factor out a 4 from the 12, which is a perfect square, right? I wouldn't want to do, say, 6 times 2 in the square root here, because neither of these are perfect squares. Okay, so you want to have a perfect square, and you really want the biggest square root that's possible. So I have 4 times 3. I'm going to rewrite this with squared terms. So 4 is just 2 squared. I can't rewrite the 3 though. Oh, sorry. Okay, so 2 squared and then times 3. Okay, the squared term comes out, so I have 2 times the square root of, and then this 3 has to stay in the square root. So 2 rad 3 is my answer there. Okay, moving on to number 3. This one looks like a bit more complicated, but still the same process. I want to think of a perfect square that goes into this. Our first class today said 16 would work, and yeah, it does. 16 times 20 gives us 320, and 16 is a perfect square. So that's one way to factor this. But if you look at 20, you'll realize there's a perfect square in this as well, right? This is just 4 times 5. So let's factor that as well. This becomes 16 times 4 times 5, all under the square root. And I'm going to rewrite this with squared terms. So this 16 becomes 4 squared. The 4 is 2 squared, and the 5 is just 5. Okay, because 5 isn't a perfect square. Okay, now any perfect squares get to go outside of the radical, and this 5 is going to stay in. Okay, so I have 4 times 2 outside the radical, and then square root of 5. And I just multiply the 4 and the 2 together, so that gives me 8. Rad 5 is a final answer. Okay, another way that I could have done this to avoid breaking up and having 2 perfect squares, I could have just found the biggest perfect square, which would have been 64. Okay, so for 320, I could have broken this up into 64 times 5. 64 is just 8 squared, and then I leave the 5 alone. Taking the square root of that, I have a perfect square with the 8, so that comes out of the square root, and I'm left with the square root of 5. Okay, so again, I get the same answer, but a little shorter method because I was able to find the biggest perfect square in this number. Okay, moving on to some more examples. Okay, so number 4 I'm trying to think what's the biggest perfect square that I could find in 18. So maybe I'll try dividing by 2. What do I get? Oh, I get a 9. Is that a perfect square? And yes, it is. So this I'll write as 9 times 2. 9 is just 3 squared, so I have a perfect square here. That comes outside of the radical, so I have 3 times the square root of 2. Okay, and number 5, 128. Okay, looking at this is not a perfect square, but I noticed that if I divide it by 2, I get a perfect square. Okay, so dividing by 2 is going to give me the biggest perfect square option, so you always want to check that first, kind of as a strategy. So you could try to divide by 2 and see if what you are left with is a perfect square. So 128, if I divide that by 2, oh, and I threw a list up here of all these of the perfect squares up through 17. Okay, so there's just some perfect squares to get you started. Again, I notice if I divide by 2, I get 64, which is a perfect square. That's just 8 squared times 2. And the perfect square gets to come outside of the square root, so I get 8 times square root of 2 as my final answer. Okay, number 6 is a little different because I have a variable, but we treat it the same way, okay? So I'm going to start by thinking about the 48 part and break it up so that I have a perfect square. If I divide this by 2, I would have 24, which is not a perfect square. But if I divide by 3, I get 16, which is a perfect square. Okay, so I'll have 16 times 3, and then I still have this x squared, so I'll just leave that under the radical for now. And now I'm going to rewrite it with squared terms, so 16 is 4 squared, 3 is just 3, and the x squared is x squared. Okay, so I now have two things that are squared. Because they're perfect squares, they get to come outside of the square root. So just like I would for a number, I'm going to bring the x out as well. So I have 4x times the square root of 3, because 3 is not a perfect square, so it stays under the square root. Alright, and a few more examples here. I just realized I have two number 6 problems. So 7 and 8 here. Number 7 is the square root of 288. I want to think what's the biggest perfect square that I can factor out of this. If I divide 288 by 2, I get 144. So I'm going to go ahead and use that as my factoring because I know that 144 is a perfect square. Okay. So moving on, 144 is just 12 squared, and I have times 2 still under the radical. 12 squared, that's a perfect square, so the 12 gets to come out. Okay, I think these kind of cancel out in a way. So I'm left with 12, and then the 2 is stuck under the square root. So 12 root 2 would be my final answer. And last one here, number 8. This one's a little different. I have an n cubed now. So remember, when we have variables raised to an exponent, it's just, or anything raised to an exponent, I should say, it's just repeated multiplication. So n to the n cubed, or n to the third power, is just n times n times n. So we want to group our variables together in pairs, so I could rewrite this as n squared times n. Okay. And then with the 27, I can't really divide by 2 to get a whole number at least, but if I divide by 3, I get 9, which is a perfect square. Okay, so I know that 9 is just 3 squared. So I have a 3 squared and I have an n squared, so each of those is going to be able to cancel and go out of the radical. And then I'll be left with a 3 and an n inside. Okay, so the first, because of the 3 squared, I get a 3. Because of the n squared, I get an n. And then I have the square root of 3n because this 3 and this n are stuck inside the square root. Alright, and these last couple slides show some independent practice problems, so try to work some of these out so you can check your answers. If you're getting stuck on the homework, you can kind of make sure you're on the right track. Okay, so spend some time on these. For x to the 4th, this is like x squared times x squared. So each of these gets to come outside of the square root once. That makes sense. So you'll see that we get an x squared there. If you want to work on these, go ahead and pause the video here. I'm going to go ahead and click forward to the answers. Okay, I numbered the problems this way, and then here are the answers to those 6 problems. And that's all for today. So go ahead, work on the homework, and I will see you tomorrow. Thanks.